Welcome back. I've got a fun experiment for you today. What I'm going to do is I'm going to put a very high voltage across some aluminium kitchen foil and see what happens. I've got some really quite simple apparatus here. I've just got 2 sheets of kitchen foil, so there's one down there at the bottom and one on the top, and they're separated with a bit of clear plastic. You can use bin liner or something like that, something that's an insulator. And the only important thing is that they don't touch. And what we'll do is connect it up to a high voltage power supply and see what happens. So I've got my crocodile clips connected to the top one and to the bottom one, separated with the piece of plastic. I'm going to connect the top one to the positive of a very high voltage power supply and the bottom one to the negative of the 5000 volt power supply. And we'll just turn it on with no volts and then just give it a bit of a wriggle. And let's turn up the voltage and see what happens. 2 things seem to happen there. Firstly, I think you noticed it was pulled down. The layer on top was pulled down toward the table, and maybe you heard some clicking. So let's look at that in a little bit more detail. So I'm going to turn up the voltage. And what you'll notice is the aluminium foil moved downwards. It's as if the 2 layers were sticking together. So let's explain that first. So when I turn up the power supply, what's happening is the top is connected to the positive, the bottom to the negative. So we take electrons off the top and make it positive, and we put the electrons on the bottom and make it negative. So we've got a positive top, a negative bottom, and those 2 will attract each other. There's an electric field between the 2, so it pulls the 2 layers closer and closer together. But we'll do a bit more now and see what happens when we turn up the voltage even further. So let's turn up the voltage again, and if you remember, the 2 layers pull together, but something else happens. At very high voltages, you hear this clicking. You might see little sparks forming. And what's happening here is the voltage is so high and the electric field so strong between the gap, it's actually breaking the plastic down in between, melting the aluminium, and you're actually getting a spark forming with molten aluminium, and it's boring a hole both in the aluminium foil and also in the plastic sheet. This device is failing badly. So what we've built here and what I've shown you is a capacitor, and a capacitor stores charge. I'll show you in a minute that it does actually store some charge. But what we did is we turned up the voltage so high that the electric field strength between the plates was so strong it caused a breakdown in the insulating layer, in the dielectric. And this is a very common cause of electronics failing at home. By pure coincidence, a pupil just came in and asked me to have a look at a laptop charger that had failed. And we pulled it apart and surprise, surprise, it was the capacitors that had failed in it. Capacitors normally look like sort of circular cans on electronic circuit boards, and what they've done, of course, to get a high capacitance is taken the aluminium foil and rolled it up into a sort of Swiss roll and put it into a can. And they come in all shapes and sizes, but their job is fundamentally to store charge. But if anything goes wrong with the dielectric, the insulating layer in between, and it arcs, it fails, the rest of the electronics is not going to cope at all. A common failure in household electronics. We have to be a bit careful when using this apparatus because if you remember, it stores charge. We take electrons off the top layer and put them onto the bottom layer. And if we were to allow them to flow back very quickly, there'd be quite a large current for a short period of time. So let's charge it up again. And you'll see the layers getting closer together. It's beginning to break down. And I'll just disconnect it and touch the 2 connectors together. Quite a spark there. So I certainly didn't want to do that whilst I was holding on to it. What you saw there was the charge neutralising, and the 2 plates are now neutral. The electrons have moved off the bottom plate and gone back onto the top one. The capacitor is empty. I'm going to turn out the lights now and see what happens when we turn up the voltage too high and we get the insulating layer breaking down. So I've got the lights out now. Let's turn up the voltage and see if we can see the actual sparks flying. This clicking you can hear, if you remember, is boring holes in the dielectric in the insulating layer. So I'll get the macro lens out and I'll see if I can get you some photographs of the actual holes appearing in the material. I've removed the plastic sheet from the capacitor and you can actually see what look like bullet holes in it. This is where the insulation has broken down and the spark forming has actually bored a hole right the way through the insulating plastic sheet, causing the two plates to short out. So, I hope you learnt a little bit more about capacitors, how they store charge and what happens when they fail, and now you might know a bit more why sometimes chargers and other electronic devices fail when you're at home. Hope you enjoyed that video and I look forward to seeing you again next time.